Hi, this is Alex from devstories.eu, NVIDIA NeMo Guardrails, episode 1 of 10. You would never connect a raw database directly to the public internet, yet many applications expose unconstrained language models directly to end users. Relying solely on a system prompt to maintain security is a fragile architecture. Today we cover the AI Guardrails imperative, core abstractions. NeMo Guardrails acts as a programmable intermediary layer sitting between your user application and the language model. It does not replace your model. Instead, it creates a separate pipeline of discrete safety checks called rails. Rather than begging the model to behave through complex prompt engineering, you orchestrate safety through this deterministic layer. Consider a customer service bot. A user sends a message, the system retrieves relevant support articles, the model drafts an answer, and it might trigger a back-end action like processing a refund. You need different types of protection at each stage. To handle this, Guardrails defines 5 distinct rail types. First, the user message hits the input rail. This rail inspects the text before the core language model ever sees it. If a user attempts a prompt injection attack or submits highly toxic text, the input rail intercepts the message immediately. It stops the pipeline and returns a predefined refusal. The main model never processes the malicious text, saving compute and preventing an exploit. If the input is safe, the system evaluates dialogue rails. These manage the expected flow of the conversation. If a user asks the support bot for an opinion on a competitor, a dialogue rail identifies the topic. It forces the bot to follow a predetermined path, perhaps replying that it only discusses its own products. Dialogue rails prevent the model from wandering off topic or answering questions it has no business addressing. Next, when your bot searches your knowledge base to ground its answer, retrieval rails take over. These inspect the chunks of text pulled from the database before they are appended to the model prompt. If a poorly configured search accidentally grabs an internal human resources document instead of a public manual, the retrieval rail detects the sensitive information and strips it out of the context window. If the conversation requires the bot to perform a task, execution rails step in. They control which custom actions the model is allowed to trigger. When the model requests to execute code or call an external tool, the execution rail verifies if that specific action is permitted given the current state of the conversation. It blocks unauthorized commands from executing. Finally, we have output rails. This is the last line of defense. After the model generates a response, the output rail evaluates the text before it reaches the user. It checks for hallucinated facts, inappropriate tone, or sensitive data leaks. If the text fails the check, the output rail intercepts it and alters or blocks the final message. This architecture fundamentally changes how you build generative applications. You stop relying on a probabilistic engine to police its own behavior, and instead build a deterministic safety net that controls inputs, logic, and outputs independently. By the way, if you find these episodes helpful and want to support the show, you can search for DevStories EU on Patreon. That is all for this one. Thanks for listening and keep building.